1.9. We're talking about the representation of functions by power series. Much better. Okay, so what is our geometric series equal to? If I write my geometric series n equals 0 to infinity a r to the n, that is equal to what? A over 1 minus r. When minus 1 is less than r is less than 1. Okay, that's our geometric series. So, if I were going to say when a equals to 1 and r equals to x, I would have the function 1 over 1 minus x has to be equal to the sum n equals 0 to infinity x to the n. Does that make sense? A is 1, so I replace, in my formula right here, I replace a with 1 and I replace r with x. And now I have a representation for the function f of x equal to 1 over 1 minus x. Now this works for minus 1 less than x less than 1. Whatever's inside, it works for it between minus 1 and 1. What we want to do is to write functions that look like 1 over 1 minus x, but they're going to be multiples in there. They're not going to be exactly the same, but they're going to be fractions similar to this, and we want to represent them as a power series without doing a whole bunch of derivatives. So what we're going to do is we're going to make them look like a geometric series. That's going to be our goal. And then our interval of convergence, just you apply minus 1 less than whatever you're raising to your n power less than 1. And that's what we're going to do. So let's do some examples. Find a power series for f of x equal 4 over x plus 2 centered at c equals to 0. So I don't need an x minus anything. I have to start with the 4 over x plus 2, and I need to switch it so that it looks similar to the form 1 over 1 minus x. This is the form that I want. In other words, I want the x second, I want that minus sign right there, and I need the 1 right here. So let's go ahead and do that. This is going to be 4 over 2 plus x. I made the x second. And now what I'm going to do is get my minus sign. Minus sign in front of x. And then I'm going to turn the 2 into a 1, and I'm going to do it by dividing everything by 2. What we get is 2 over 1 minus x over 2. So in this case, a is going to be 2, r is equal to minus x over 2, and I plug it into my geometric series. Sum n equals 0 to infinity, 2 times minus x over 2 to the n. And there is my power series representation for that function. There's going to be more than one power series representation, but there is only one power series representation using this form. You can get what looks to be like different power series representations if you use the derivatives and stuff. If you simplify them, they usually end up being the same form, but it's going to look different. So here's a power series representation for 4 over 2 plus x. What I want to do now is determine where it converges. So that means minus x over 2 has to be less than a minus 1. I'm going to do it this way. Absolute value of x over 2 is less than 1. That means absolute value of x is less than 2 by multiplying both sides by our 2. And then that tells me minus 2 is less than x is less than 2. There's our convergence. Notice we do not have to check endpoints on this. I already know geometric series does not converge at the endpoints. So I don't have to check the endpoints. Oh, that's a really short spelling. Leave the middle terms off. Okay, what's very important about what I just did is the steps that I just did. And I wrote them out there so that when you go back to study later, come back to this first example to try and figure it out. Because those are the steps you're going to want to do in that order to do all of these. If you do them in that order, it makes life easy for you. If you try and switch up the order on it, it's going to make life difficult for you. Those are the steps you want, and that's the order you want to do those steps in. Any questions on that? Okay, let's do another one then. Find a power series for g of x equals 4 over 3x plus 5. This one looks harder, and it's at c not equal to 0. So I have 4 over 3x plus 5. The first thing I do is I switch it to make x second. So that's 4 over 5 plus 3x. I didn't have to put the c in last time, but I have to put the c in this time. So I'm going to add and subtract. It's going to be 5 plus 3 times x minus our minus 2 plus the minus 2. And that's the order I'm always going to put it in. Let me move this over. So when you do that, do x minus c plus c and do it inside your parentheses. Now what we're going to do is we're going to group the first two terms together because that's my x minus c. And I'm going to take the second one outside. And when I take it outside, I have to multiply it by that 3 right there. So this becomes 4 over 5 plus 3 times x minus a minus 2. And then I have plus 3 times that minus 2. Simplify this. What is 3 times a minus 2? Negative 6. Negative 6 plus 5? Negative 1. So I have negative 1 plus 3 times, and now that becomes an x plus 2. Now I've got it in the form that I need, except I have to put my minus sign right here. Okay? I'll be pedantic about the steps. It's going to actually cancel in a minute. So if the minus is missing from right here, we're going to introduce it. And now I have to divide to make that be equal to 1. So what should we divide by? Negative 1. Simplify that. I get a negative 4 over 1 minus those two negative signs right there are going to cancel and give me a plus. And I get 3 times x plus 2 with that minus still there. Now, this is equal to A is our negative 4. R is our 3 times x plus 2. So it becomes our series n equals 0 to infinity. Negative 4 times 3x plus 2 to the n. And we have to determine where this converges. I'm going to do that over here. you're going to take your 3 times x plus 2, set it less than 1, do our minus 1 on both sides. I'm going to write that as 3x plus 6. Subtract 6. I'll do that in a different color. And we have a negative 7 less than 3x is less than a negative 5. Divide by 3. And I have negative 7/3 is less than x is less than negative 5/3. And there's the interval of convergence. There's our power series representation. Yeah. We are dealing with the geometric one today. This is the easiest form. Next time we have to do the infinite number of derivatives. Yeah. Yay. This is the easiest one. Double derivative. Geometric n always equals 0. So we start. That's how we get to our formula. If you start n equals to 1, then the formula is wrong. Yeah. The other times it doesn't matter what it starts with, so we can restart it with 1. Question? Geometric series averages in place. If you just think of A, R to the n, and R becomes 1, then you just have that 1 to the power that is a constant. So its limit doesn't go to 0. And if you have a minus when it flips back and forth, you minus 1 and 1, its limit doesn't go to 0. If you plug in minus 5/3 into that series over there, you'll get a 1. And that's why it doesn't actually go to 0 on the limit. So nth term has to be the Yeah. Any other questions on that? Question?
Okay, so when we're in this equals derivative, I just feel like it's kind of a pointless step. Curious as to what the minus 2 plus.
Yeah, if you just had simplified right here, that would cancel.
Okay.
I don't want to change my equation. See, I have all of these equal signs. That means the very first equation is equal to the very last equation down here. So I can't add something without subtracting it. So at that point, don't simplify it. Keep the first two together, take the last one out, and combine it with your number here at the beginning. Yeah, that's what we're doing. So we're sort of splitting things up and balancing them. Yeah. Any other questions on that? Okay. You guys get to try one. Yours is centered at c equals to 1, and you have f of x equals to 1 over x. That means if you wanted to write it as anything, that would be 0 plus x to get that first term in there. But that's where you're starting. You guys all have the handout, right? So I can put it up on the previous slide. You can watch it go by. On that first one, make sure you tell me the interval that it converges on to.
A positive one, a positive ten. Minus one, plus one, that's two. Minus plus. Yeah. And it always is
Okay, do we all have it done? What did we get for an interval convergence? 0 to 2. Don't say negative 2. Who said negative
And
transition to the next topic. So operations with power series, what you can do is you can plug in values, f of k times x. So you're going to plug that in wherever you had seen an x. So if we know f of x is equal to a sub n x to the n, then you're going to plug in k times x where you see that x right there, and you'll get kx to the n, which is our k to the n x to the n. So that works. You can plug in x to a power, and it's multiplicative, and you can add and subtract your power series from each other. When you add and subtract your power series, you're going to take the intersection of your intervals of convergence. So it's where your intervals overlap that your new interval of convergence is. I always have a test question dealing with this one right here. I'll give you two power series. They'll have different intervals of convergence, but one of them will say be up here, and another one will be down here. And you will tell me that the interval of convergence is where they overlap. And you'll have to tell me that. So there will be a test question dealing with that one. Let's look at example. This one says find a power series centered at 0 for f of x equals 3x minus 1 over x squared minus 1. On your homework, you have to do the partial fraction decomposition. To save time in class, I did it beforehand and I'm just writing it down. So this part right here would be a partial fraction decomposition. Sounds like that's our favorite thing. It won't be that difficult. It'll be linear terms, so it's not a hard partial fraction decomposition. You have to factor yours first before you do your partial fraction decomposition though. So you have to factor it and then do the partial fractions. Then it says find an interval of convergence for this power series by considering the interval of convergence for the original power series. So let's look at 2 over x plus 1. What is our first step? Put x second, right? 1 plus x. C is 0, so I don't have to plug in for c. So this is 2 over 1 minus 1 times x. So our power series for this is going to be 2 times minus 1 times x to the n and equals 0 to infinity. That's our power series. Now what is the interval of convergence for this one? We're going to have minus 1 times x in absolute value less than 1. The absolute value cancels with the minus 1, and I have minus 1 less than x less than 1 for the interval of convergence. Let's look at the second power series. I have 1 over x minus 1. Write the x second one together. Minus 1 plus x. Get our minus sign. And then divide everything by minus 1. And notice that the minus 1s are going to cancel. And this becomes minus 1 over 1 minus x. In the power series notation, a is minus 1 times x to the n. And the interval of convergence is just minus 1 less than x less than 1. It's the same interval of convergence as the previous one. Now let's add them together. 2 over x plus 1 plus 1 over x minus 1 is going to be the sum n equals 0 to infinity. 2 times minus 1 times x to the n plus n equals 0 to infinity minus 1 x to the n. Notice we can combine our x to the n's. We have this x to the n right here and this x to the n right here. I'm going to combine them into one series and factor out that x to the n. We're going to do that all in one step. So this becomes our summation n equals 0 to infinity x to the n times 2 times a minus 1 to the n minus 1. And there's our series. And it converges on the intersection of minus 1 to 1, which is just minus 1 less than x less than 1. Any questions on that? So this just combined adding the two series together. You have one like that on your homework. Can we do that? Once partial fraction decomposition is done, it's not hard. That's the hard part of this question. Okay, you guys have one. I did the partial fraction decomposition for you. You're welcome. I don't want you to take too much time on it. I'm going to bump it up to the previous slide so you can watch the previous slide. You can look at it because watching is quite the right term. What? It's centered at c equals 0.
Okay, so this is it.
Yeah, I forgot to put that down. Okay, compare your answers with each other. Does everybody have the same answer on that one? And let's go to our last topic for today. Find a power series. Phi of x equals arctangent x centered at c equals to 0. What is the interval of convergence for this power series? Now you're going to look at it and go, there is no fraction there. I would submit to you that I have it well hidden, but there's a fraction there. What is the derivative of arctangent of x? 1 plus x squared. That is going to be the same thing as 1 over 1 minus a minus 1 times x squared. This is my r, and this is my a. So I'm going to have 1 is a, and then my minus 1 to the n, x squared to the n. But what is x squared to the n? X to the 2n. That is the derivative of the arctangent. Last time I checked, arctangent of x is the integral of the derivative of the arctangent of x. So what we have to do is we have to integrate our series. How to do yesterday's lesson with today's lesson. Minus 1 to the n is constant, and I have x to the 2n dx. What is the integral of x to the 2n? Add 1. Plus 1. That's exactly what you meant. Plus 1, yes. Over 2n plus 1. There's our integral. And of course, we need our plus c. Solve for c. So what do I know about the arctangent of 0? What is arctangent of 0? Okay, yes, it is 0, but why? Do we remember our arctangent graph? Sorry, wrong one. I'm teaching this in pre-calculus. I should know it. Give you the wrong one. Arctangent of 0, 0. Goes through the origin. This is all equal to the arctangent of 0, so 0 has to be equal to, when I plug in x equals to 0, what is 0 to the 2n plus 1? 0. So this whole part here is 0. So that's just equal to c. So we have c equals to 0. Therefore, the arctangent of x is going to be our sum, n equals 0 to infinity, negative 1 to the n, x to the 2n plus 1 over 2n plus 1. There's our arctangent. Now notice it says, and find the interval of convergence for the power series. So go back up to the original series, and you have the whole minus 1 x squared has to be less than 1, or minus 1 is less than x squared is less than 1. Well, let me do the square root first of all. If you take the square root of both sides, you're going to have x is less than plus or minus 1. In absolute value, so minus 1 is less than x is less than 1. Got rid of my x squared. So my interval of convergence is minus 1 to 1. However, when you integrate a power series, you have to check its endpoints. I know on the original series that the endpoints, it diverges at the endpoints. Using the shortcut rule, that means I have to check both endpoints because it diverges at both of them. So let's check x equal negative 1. we have the sum n equals 0 to infinity, minus 1 to the n, minus 1 to the 2n plus 1, over 2n plus 1. Combine your minus 1 to a power. That means we add our exponents. I have n plus 2n plus 1. What does that give me? 3n plus 1. Three n plus 1 switches between even and odd and even and odd. When n equals to 1, you have 4, even. When n equals to 2, you have 6 plus 1, odd. It switches between even and odd and even and odd. So this is the same thing as an alternating series. So use the alternating series test. Limit as n goes to infinity, 1 over 2n plus 1. What is that limit? 0. And then is 1 over 2 times n plus 1 less than or equal to 1 over 2n plus 1? Yes. So converges, the series converges by alternating test. So I know the first endpoint is going to contain minus 1. Let me get another piece of paper. And let's look at the second endpoint. X equals to 1. Now help me out. 1 to the 2n plus 1. What does that equal to? 1. So this just becomes a sum n equals 0 to infinity minus 1 to the n over 2n plus 1. That is also alternating series. So by the previous work, the series n equals 0 to infinity minus 1 to the n over 2n plus 1 converges by the alternating test. So what does that tell us? 1 to 1 is our endpoints for it. Here's our answer. Okay, question?
How do you determine that C equals 0 and let you know that arctangent is that?
Because I knew that arctangent, I started with this guy up here, this arctangent up here, and I got equal signs all the way down to here. So, yeah, if you plug in 0 for x here and 0 for x here, set the two equations equal, you can solve for C.
Okay, but so that lets you know that C is 0 in the original.
No, that says that this guy right here is 0.
Yeah, okay, that's in the derivative, though, right?
No, that's actually after I integrated.
Oh, yeah, I see.
So I took this through, integrated it, I got this constant of integration. That goes to 0, so that says that's equal to the summation.
So C is equal to another number.
That number plus the series,
Okay.
yes.
Okay,
Question.
so you said the whole thing equals to 0 because it's vectored at 0, right? Like
No,
zero
because I know arctangent of 0 is 0. I picked a number so that the arctangent would be easy to evaluate.
Okay.
Yeah. I could have just as easily picked pi over 4, but inside this series that when you plug in pi over 4 for x, you actually have a straight answer. So choosing 0 to plug in is a good place to start. Okay, guys, when you're submitting this on Gradescope, put a skip on that third problem, and it's going to ask you for a picture of it. So put skip on it, and then take a picture of that and put it up on Gradescope for that third problem. That way, the grader will know to skip that one. That third problem on your classwork. So in other words, we don't have time to do the last problem. Yeah, so write skip for the third problem and take a picture of that. Yes. Yeah. Let me turn off my recorder and then I'll come back.